To guarantee the photographic recovery in a normal case, there are special cameras, called stereometric cameras. In essence, these are two cameras with lenses of a certain quality, that is, that they are practically free from distortion, which are placed at the ends of a bar of a certain length. In the case we see, the bar is 1 meter and 20 meters long. These findings were made following the 1980 earthquake. As you can see, there are no other systems that can ensure rapid and, say, risk-free measurements, such as in the case of an earthquake, fire, or any other event, in which the object to be detected becomes inaccessible. In the particular case, the operators are part of the photogrammetric unit of the Urban Police of Bari, of the municipality of Bari, which was the first municipal police to have a photogrammetric unit. As you can see, the recovery is enough. On a photographic level, it is quite simple. It is about arranging the tripod at a certain point, make sure, but this is also a relative fact, make sure that the bar is horizontal, and for this the system is equipped with a spherical level. And then there are two orthogonal Turek levels, applied precisely to the stereophotogrammetric chamber. It is a matter of placing the camera, framing the subject to be detected and photographing it. Having this camera, the base of 1 meter and 20, it can make shots at a distance between a minimum of 6 meters and a maximum of 24 meters. So if we shoot an object at 6 meters, we will see it as an object placed at 25-30 centimeters from our eyes. Theoretically we have the maximum precision, but it bothers us to observe it so closely. When it is at 24 meters, it is excellent as a stereo vision, but it begins to be, let's say, not very precise, but requires some attention to measure. This room accepts 6 by 9 photographic plates. Considering that they are no longer available, we have always used slides, on which we applied flat films of the format 6 by 9. In the areas affected by the earthquake, about 3,000 plates were impressed, and all these frames are now online, on the laboratory website, in the photogrammetric catalog, and can be consulted from home. Also as regards the possibility of detecting the measurements on the photographed objects. Here we see the photogrammetric catalog, where you just have to choose the location or name of the monument that interests us, or other data shown in the catalog, and with a click we can have, in real time, all the frames of that monument. Always with a click we have stereoscopic couples and, very importantly, not only can we see them in stereoscopy, but we can also take the measurements we want. The stereoscope, which you see on the table, is very simple, made of aluminum, even with aluminum mirrors and without lenses. It only serves to make the pair of frames be observed on a 20-inch panoramic screen. On this pair of frames, thanks to a fairly simple program, we are able to move a mobile brand and know the coordinates of the brand itself. The reference system, when we take the shot with this camera, has the origin in the left camera, the x-axis according to the base, the y-axis according to the optical axis of the left chamber, and the z-axis orthogonal to the plane determined by the first two. So if the camera is horizontal, the Z-plane will be horizontal. If tilted, it will be tilted. In fact, this camera can be tilted 14, 30 and 60 degrees, upwards or downwards, and 90 degrees for zenith shots. By archiving the plates with these data, in real time, we have the possibility to take all the measures we want. How is it possible to take these measures? And here we see, on the screen, a fairly simple scheme. On the basis of the similarity of triangles, it is possible to obtain the coordinates x, y, z of a point on the ground, thanks to the images of this point on the two plates. It is clear that, to do this, we will need to know the room we are using. In particular, the distance between the projection center and the plate, which is not the focal distance, but the distance between the projection center and the plane of the plate at the time of shooting. The stereometric chamber, in particular, has a fixed focus, so the distance is provided by the manufacturer. And if, as you can see, this distance has to do with the calculation of y, it is clear that the more precise the measurement. In the case of metric chambers, the precision with which it is calculated. This distance is 1/100th of a millimeter. Another element to know is the intersection point of the perpendicular to the frame with the frame itself, what is called the main point, and is the origin of the reference system xy, from which we obtain the coordinates of the corresponding points. Therefore, with any program, by detecting the coordinates of the corresponding points from each frame, it is possible, in real time, to have the ground coordinates of the point. In the particular case, the program that we use in the laboratory, by clicking on the left frame, we have the coordinates of the left point. By clicking on the right frame, we have the coordinates of the right point and the ground coordinates, in real time, of the detected point. It is clear that by moving to another point and taking the coordinates, if the former have been memorized, it is very easy to always have the distance between the 2 points in real time. Then we will see how it will also be possible, in addition to detecting the ground coordinates, knowing the ground coordinates of the point, to detect the coordinates of the corresponding points on the 2 frames. The first is called direct frame. In the second case, that is when we get the coordinates of the image points on the plates, we will talk about inverse photogrammetry. And this will serve us above all for the planning.